Hi and welcome to Introduction of Apache Spark. My name is Nishant Garg and I will be your trainer for this video. In this section of videos, we are going to talk about the introduction of Apache Hadoop. Next, we will talk about Hadoop processes and Hadoop components, HDFS, YARN and MapReduce. And in the end, we will talk about Apache Spark execution model. Now we move on to the first video of this section, Introduction of Hadoop. In this video, we are going to look at the history of Apache Hadoop and what is Hadoop. Let's start with history of Hadoop first. Apache Nutch was originated by Doug Cutting in 2002. Nutch is highly extensible and scalable open source web crawler software project. In June 2003, a 100 million page demonstration system was developed by Nutch team to meet the multi-machine processing needs of the crawl and index task. In October 2003, Google published a paper named Google File System. This paper, which becomes the basis for Hadoop distributed file system. Google File System is a scalable distributed file system for large distributed data intensive applications. Google File System provides fault tolerance while running on inexpensive commodity hardware. Later in 2004, Google published another research paper called MapReduce, the simplified data processing on large clusters. It is a programming model and provides reference implementation for processing large distributed data sets. Apache Nutch was the first project to start the implementation of distributed file system concept and MapReduce processing model. Later in January 2006, the implementation is moved to new subproject called Hadoop in Apache Software Foundation. The initial code that was factored out Nutch considered of 5,000 lines of code of HDFS and 6,000 lines of code for MapReduce. And later in 2008, Apache Hadoop became the top level project for Apache Software Foundation. Let's spend one more minute for recalling Spark history from the last section. Spark is an open source project that has been built and is maintained by open source community of developers. A project Spark was started in 2009 as a research project by Mitai Zaharia at the University of California Berkeley AM Labs. Mitai Zaharia later co-founded Databricks, which is now the main force behind Apache Spark, contributing more than 70% of Spark codebase. Researchers working on Hadoop MapReduce realized that MapReduce is inefficient for computing jobs which are iterative and interactive in nature. Therefore, from the beginning, Spark designed to support in-memory storage and efficient fault recovery that makes it fast for batch applications, iterative algorithms, interactive queries, and stream processing. Spark was first open sourced in March 2010 under Berkeley Software Distribution Licensing Scheme, and later it was transferred to Apache Software Foundation in June 2013. In 2014, Apache Spark becomes the top level project at Apache Software Foundation. Apache Hadoop ties together a cluster of commodity machines with local storage using free and open source software to store and process vast amount of distributed data at a fraction of cost of any other system. Hadoop framework addresses the data intensive process bottlenecks. Out of number of bottlenecks in the computing world such as like CPU, RAM, network or disk IO, Hadoop is designed to solve the problem of disk IO. Hadoop is designed to scale massively. In order to achieve scalability, Hadoop uses redundancy and avoid the need for any sharing of the single system, such as locking files for operations. The Hadoop file system is write once and files are immutable. Hadoop processes all the contents of the file. While processing, Hadoop assumes that an application will read either the whole file or a directory of files. The reasoning is that in order to satisfy the goal of massive throughput, the most efficient use of the disk is to have it spend most of the time transferring data, not seeking to find data. Hadoop is very fast for big jobs. 50 node cluster with 10 disks per machine running a large MapReduce job will have close to 500 disks reading and processing data all at once. The relative speed of work done in parallel when compared to non-parallel system will be significant. But if the data is small and could fit on a single machine, then you will find that Hadoop is slow compared to other systems. In general, if you think 5 minutes is slow, then perhaps the problem you have is not suitable for Hadoop to solve. No caching, no indexes. Hadoop does not provide any feature, although HBase and other apps built on top of Hadoop provides caching and type of indexing. Designed for hardware and failures, Hadoop works on sharing nothing principles. Core Hadoop systems are designed to share as little information about state as possible. Nodes does not know what file or block of file it contains, and data processing task is either running to success or fail completely. And subsequent attempts do not require state from the failed task as well. Nodes containing the data has the simplest job to do is to read the file block when requested. All these features put together create a powerful processing framework that not only stores large amount of data using HDFS, but also process large amount of data in relatively short amount of time using MapReduce. In short, big data and Hadoop have become the synonyms to each other. Hadoop is also major reason and driver for creation of Spark. Therefore, Hadoop and Spark are closely linked to each other, and Hadoop continues to be a key platform for Spark. In this video, we have discussed the history of Apache Spark and what is Hadoop. In the next video, we will talk about Hadoop processes and Hadoop components. Thank you.